Our next lesson is Chapter 6-9a on probability. In probability, we often talk about outcomes. An outcome is any of the possible results that can occur. Let's say, for example, that you are rolling a 6-sided die. A result could be to get a 1, or a 2, or a 3, or a 4, or a 5, or a 6. Now the event would be the collection of possible outcomes in an experiment. If I'm going to roll that 6-sided die, I might want to know the probability of getting a 3, or the probability of getting a 1 or a 6. That would be my event, to get that 3, to get that 1 or 6. Let's move on to an example. Suppose that the following shapes were cut out of paper and placed in a box. You get to choose a piece of paper at random. There are 2 triangles, 2 squares, and 2 circles. Now you really have 3 possible events: selecting a triangle, selecting a rectangle, and selecting a circle. The probability of an event, whether it's selecting a triangle or a rectangle or a circle or a combination of those 2, is given by using the following formula. Now note that the outcomes have to be equally likely. The probability, that's the capital P, of the event, which we put in parentheses, is the number of favorable outcomes, what we want to get, out of the total number of, or over, the total number of possible outcomes. It's really a form of a ratio that we can express in a fraction form and then in a percent form as well. The first thing we're going to do is that they want us to find the probability of selecting a triangle. Now, if you remember back in the box, and you can see up here, here's our box, we can get 2 triangles. 2 out of 1, 2, 3, 4, 5, 6 possibilities. So this is the favorable outcome. And the 6 is our possible outcomes. And we really have 6 possible outcomes here. Now we are usually going to express this in lowest terms. We're going to get 1/3. Let's look at the probability of getting a circle or a square. Now this one, this or, becomes a very powerful word because it means you can pick either the circle or the square. Therefore, since there are 2 circles and 2 squares, we have 4 favorable outcomes over our 6 possible outcomes, which is going to be the fraction 2/3. In C, they're asking us to find the probability of choosing a pentagon. There are no pentagons in the box. Therefore, there are 0 favorable outcomes over the 6 possibilities. So our probability is a 0. If they had asked us for triangle or circle or square, that would be 6 out of 6, and that would be expressed as 1. Try that again. Or a square or a circle. Now, there are 6, so 6 out of 6 would equal 1. In the second part of the lesson, they're going to ask us to take those probabilities and not only express them as fractions, but that we also can express them as percents. Now, we've already covered getting from fractions to percents earlier in this chapter. So this kind of pulls a couple things together. So obviously this is one of our practical applications of percent. In example A, the probability of a professional golfer getting a hole-in-one in a single round of golf on a PGA course, Professional Golf Association course, is 1 out of 3,709. Express this as a percent to the nearest thousandth of a percent. This goes back to chapter 5. That is our ratio language and tells us how to set up the fraction. 1 out of 3,709. We want to express that as a percent. So we're going to use that calculator. 1 divided by 3,709. We're going to hit that second function key, that percent key, and that equals key. Now you are going to get quite a decimal. 1.0269145, and that is a percent. Now you'll notice that they tell us we want to go to the nearest thousandth. That's the 6. The 9 has to tell us whether or not to stay at 6 or go up to 7. And since 9 is much closer to the 7 than it is to the 6, we know that our probability here is approximately 0.027%. In sample B, they are going to have the probability of having identical twins is actually 1 in 274. Express this as a fraction and as a percent to the nearest thousandth of a percent. Hit pause, and you do this one. Did you get your fraction set up correctly? Did you get the correct percent? 0.365. Did you remember to use a percent sign? Again, hit pause, and you do example C. And yes, at the time that I was taking this, writing this down, the probability of hitting a half-court shot in basketball is really 1 out of 1,200. So you try it. The fraction is going to be 1 over 1,200, and with using the calculator, you should have found a percent of 0.083%. That concludes the lesson over chapter 6-9A. Please respond to me with Batman. Catch you later.